Yes, in the last class we have seen the how to write the tabular column. Okay. After writing the tabular column, we have to write the equations. Okay. Just I will explain how to write the equations for the next. After writing the tabular column, we have to write the first equation. Okay. First equation consists of these two factors, that is 50 and j omega. Okay. And the third factor, second equation consists of that is 50 j omega and 0.5 to j omega plus 1. And the third equation consists of all the factors. Okay, like this we have tried the third equation. Okay, first equation is that I will write now. Okay, 20 log 50. If the factor is in the numerator, then we have to use plus. If the factor is in the denominator, now we have to use minus. Okay, 20 log 50. Okay, minus 20 log omega. Okay, I have considered these two factors. Okay, and I have taken the only omega. I have not taken the j omega. Okay, after writing this equation, here we have to use the two values. We have to use the two values. The two values will depend upon the your last column of the tabular column. Okay, tabular column, whatever the last column you have taken, depending upon this, we have to take the values. Okay, 20 log 50 minus 20 log omega, and the here value should be 0.1 to 2. Okay, here the value should be omega value should be 0.1 and here 2. Okay, if you substitute the 0.1 here, okay, and if you substitute the 0.2 here, 0.1 and 2, then whatever the values you are getting, okay, I will write here that values. Okay, if you substitute the 0.1, then you are getting the value as that is 53.97. We will make the approximation as 54 dB. 54 dB. Okay. When you substitute the 2 in this equation, okay, omega is 2, then we are getting the value as 27.95. 27.95. Again, we will make the approximation to 28 dB. 28 dB. Okay. This is regarding the first equation. Okay. Next, second equation. To write the second equation, again we have to use the same equation. Along with that, we have to consider the one more factor. Okay. See, for the first equation, we have to consider this 50 and j omega. Now, to write the second equation, we have to consider the 50 j omega and 0.5 into j omega plus 1. We have to consider these three factors. Okay. I will write here. That is 20 log 50. 20 log 50 minus 20 log omega. Okay, up to this one same. Again, I will write minus because minus factor is in the denominator. Okay, next 20 log 0.5 into omega we have written. Okay, 0.5 into omega. Okay, bracket 0.5 into omega we have written. Okay, here only we have to use omega. Here we have to use the 0.5 into omega. And here the range is we have to use this 2. Okay, and next value is 2 to 20. 20 we have to use. Okay, we have to substitute the first value as 2 in this equation. Omega value as 2, and next value as omega is equal to 20. If you substitute the omega is equal to 2, again you are getting the same value, that is 27.95. Okay, we'll approximate that value to 28 dB. Okay, then you substitute this as 20. Okay, omega is 20. Then you are getting the value as, I will write here. Then you are getting the value as minus 12.04. Minus 12.04 dB. Okay, see here we can write this value as approximately minus 12 dB. Minus 12 dB. Okay, here what is happening here? See here, at 2 your value is 28 dB. At 2 your value is 28 dB. At 20 your value is minus 12. Okay, that indicates, see here we are having the one line. Okay, see this is the 20 and this is the 30. At this point you are having the 28 something. At this point you are having the say around 12. Okay, see we will consider this line as 0 dB line. The line is crossing the 0 dB line. the line is crossing the 0 degree. See, this value is 28 and this value is minus 12. Okay, hence what we have to do in this equation, we have to equate this equation to 0 and find out the value of omega. We have to equate that equation to 0 and find out the value of omega. Okay, then what happens? Just we can see here. Okay, see here the value is changing from positive to negative. Hence what we have to do, we have to equate this equation to 0. 0 ಗೆ equate ಮಾಡಬೇಕು. Then we have to find out the omega value. Then what happens? When omega is equal to 10, you get the value as 0 dB. You get the value as 0 dB. Okay, just you have to equate this equation to 0 and we have to find out that omega value. Next, third equation, that is 20 log 50 minus 20 log omega minus 20 log, okay, that is 0.5 into omega, this is omega, minus 20 log, what we have write? 0.05 into omega we have write. 0.05 into omega. Okay, here what is the range? We have to take the range as, okay, we have to take the range as 20 is the starting range, because here we have stopped at 20 and this range must be more than 20. You can use 30, 40, 50, 60, something like that. Okay, I will use 100. Okay, then if you substitute the 20 in this equation, again I am getting the value as minus 12.04 dB. Okay, that is approximated to minus 12 dB. Okay, if you substitute the 100, then you are getting the value as minus 54 dB. Minus, that is 53.97. Again here also you are getting 53.97. Okay, then we can approximate this value to minus 54 dB. Okay, this is the values relating for the equation. Okay, this is the first step in the graph, not graph, in the bode plot. This is the first step. First thing is you have to write this equation, then you have to write the tabular column. After writing the tabular column, you have to write these equations. After writing these equations, again next we have to go for that phase angle equation. Okay, this is regarding the up to this magnitude plot. Next one is phase angle curve. Next value is phase angle curve. Okay. To write the phase angle equation, first we have to write the phase angle equation. Okay, after that we will see. Okay, phi of omega is equal to, that is phi of omega is equal to, see here we are having the total 4 factors. We have to write all the 4 factors that thing. Okay, here we are having the one concept, that is tan inverse of coefficient of imaginary part divided by real part. We have to write coefficient of imaginary part divided by real part. We have to write. Okay, if the term is in the numerator, then plus. If the term is in the denominator, then we have to use minus. Okay, just I will repeat once again this one. Tan inverse of coefficient of imaginary part divided by coefficient of imaginary by real part. If the term is in the numerator, then we have to use plus. If the term is in the denominator, then we have to use minus. Okay, just I will write here that for all the factors. We can write this 50 as 50 plus j0. We can write 50 plus j0. Okay, then I will write the term for the 1, 2, 3, 4. Okay, first I will write for this one. This is in the numerator, hence I will write the plus. Okay, then I will not write anything. Tan inverse of, what is the coefficient of imaginary part here? 0 divided by 50. Divided by 50. Okay, minus this part is over because next I will come to this part. Okay, this is in the denominator, hence I will come the minus tan inverse of, okay, what is the coefficient of imaginary part? That is omega divided by, what is the real part? Here there is no real part. We can write this one as 0 plus j omega. Okay, there is no real part, hence we can write here 0. Okay, minus, next third factor, tan inverse of, that is 0.5 into omega, 0.5 into omega divided by 1. Okay, next minus tan inverse of 0.05 into omega divided by 1. Okay, we are calling this equation as the phase angle equation. Okay, after writing the phase angle equation, we can make some corrections here. That is phi of omega is equal to, see here, 0 divided by 50. Okay, 0 divided by anything is 0, hence tan inverse of 0 is 0. Okay, this total term will become 0. Okay, next, anything divided by 0 is infinity. Tan inverse of infinity is 90. Because tan 90 is infinity, hence tan inverse is 90 degree. Minus 90 degree minus tan inverse of, I will write that one as it is, tan inverse of 0.5 into omega minus tan inverse of 0.05 into omega. Tan inverse of 0.05 into omega. We will call this as a equation number 1. Okay. After writing this equation, okay, what we have to do? We have to equate this equation to minus 180 degree. Here we have to use the, instead of phi of omega, we will equate this equation to minus 180 degree, and we have to find out omega value. Then we are getting the omega value as that is 6.32 radian per second. 6.32 radian per second. Okay, see here we have got the omega value as 6.32, and we have got the one more omega value when